Okay, good day friends. Right now let's try to solve the problem number 2, and this problem is not even about much of a torque. We can solve this problem by simple dynamics, and let's try to do it. A smooth thin hoop of mass m hangs from the wall on one nail A and rests on another nail B. The radius drawn from the center of the hoop to nail A forms an angle alpha with the vertical. The radius drawn to nail B forms an angle beta with the vertical. Find the force with which the hoop acts on each nail. Okay, we need to find well, N1 and N2. Let's call this thing N1. Yeah, this one. We definitely know that this is the normal force that is acting on the hoop by the nail number 1. And in this case, let me write it like this. Yeah, this is the second one. This is just normal force 2. Yeah, let me write it something like this. Okay. And we need to find just these meanings N1 and N2. Well, it's not that hard because we just can divide those two into components. Yeah, let me divide this one into two components and this one into two components, like this. Yeah, and we definitely know that that this angle is beta as well. Why? Because we know that the law of z, this, and this. If this is beta, this is beta. Yeah, basically it's not that hard. And we definitely can say that this is n2 cosine beta. Yeah, but we need to note that this is beta, not alpha. Those two angles are different. This is right now n sine beta. N2 sine beta, I'm sorry. Okay, good, good. What about this case? Well, in fact, if this is alpha, this one, it's totally the same no matter where we put this vertical line. This would be alpha. If this is alpha, this is alpha. The same thing goes for this angle, and that's why that's got to be just alpha. Yeah, this angle got to be alpha. Okay, good. Yeah, let me choose pink so it was visible. Yeah, and you can definitely say that this is n1 cosine because it's adjacent. Yep, cosine alpha. This is not beta. This is n1 cosine. Sine. I'm sorry. Yeah, n1 sine alpha. Okay, okay. One more thing to note, we've got one more force, which is just at the center, this one. This is not a nail, this is just a central point, but anyway, we know that here we must have our mg, the mass of this hoop, and the gravitational acceleration. Yeah, this is the weight, the center of mass. Okay, and we need to find just n1 and n2. Right now we can just write a simple dynamics. We know that this thing is not moving in this case, that's why just the sum of forces. Yeah, sum of forces. Does not matter if it's horizontal or vertical, both of them are equal to 0 because it's not moving any direction. Yeah, this is just 0. What our forces are in vertical direction, basically these are n cosine alpha and n1 cosine alpha and n2 cosine beta are trying to move this thing upward, but mg is working against them. So this is n1 cosine. Right now we're working with y direction, it's just vertical. Cosine alpha plus n2 cosine beta minus mg equals 0. So why? Because it's not moving, right? They're in equilibrium, I would say. And yeah, this would be just, we can move that mg to that side and we'll have some formula. But for right now, it's not that much important. What about this case? Let's work right now with horizontal forces. And horizontally, we've got only two forces, which are n1 sine alpha and n2 sine beta, which are opposing each other with no any other force, which means that those two are in perfect equilibrium. But yeah, let me write it like this. This is y, this is x. But let me write it something like this: n1 sine alpha, minus n2 sine beta, because those two are against each other, and 1 sine beta equals 0. And if I just move one of them to another side, it's got to be just n2 sine beta. Yep, that's good. Okay, this would be very important to us, this one. Why? Because right now we can do something like this. I can give a meaning to n1. It would be just n2 here sine beta divided by sine alpha. Yep. Yeah, let me just move it somewhere here. Yeah, that would be better. Right now I can take this thing, and put it here. Yep. And in that case I would have something like this. Let me write with blue so you can see it better. Just instead of n1 I put this n2 sine beta sine alpha. We also have here cosine alpha, and here we have plus n2 cosine alpha, cosine beta, I'm sorry, cosine beta equals mg, because we just move mg the another side, right? What can we do? We can just write it as cotangent, yeah, but instead let me give meaning to let me multiply all of them by sine alpha, and later on you will see why. So this thing's got to be just n2 sine beta. Just if I multiply all of them, yeah, this one to sine alpha, this this side to sine alpha, and this side to sine alpha, you would see something like this. Instead of writing all of those things as cotangent, it's got to be just yeah, this sign and this sign is gonna cancel out each other. Yeah, this one and this one. In yeah, sine beta and cosine alpha. Yeah, we've got also cosine alpha. We shouldn't forget about that. This thing's got to be n2 cosine beta sine alpha, and this thing's got to be just mg sine alpha. Okay, good. And we can take n2 as a common factor outside, and then you would see that inside of the brackets we've got what? We've got this thing, sine beta cosine alpha, cosine beta sine alpha. Between them we see this plus. What is it? It is definitely sine alpha plus beta. Yeah, or beta plus alpha, does not matter. This has got to be something like this. Yeah. So if you get distracted, let me write it totally. Yeah, this thing, sine beta cosine alpha plus cosine beta sine alpha equals mg sine alpha. And n2 inside this whole thing, this thing, this whole thing is a formula for sine alpha plus beta. It's got to be mg sine alpha. Yeah, that's why I gave sine alpha to each one of them. Yeah, I multiplied each one of them by sine alpha because it would give us this kind of pretty answer. Yeah, if it was cotangent, this still would be correct, but this looks better, I would say. And if I want to find the meaning of n2, it's just n2 here mg sine alpha. Sine alpha. Here we've got sine alpha plus beta. Okay, good. This is our answer number 1. We have found what is the meaning behind n2. Okay, what about n1? What about n1? We definitely know that n1 is just n2 multiplied sine beta sine alpha. Okay, instead, let me do the same thing. Let me write it with red, yeah, because at the very start we've noted n1 as red. n1 equals n2 sine beta divided by sine alpha. And I would put just this thing here, everything. So in that case, it would be just n1. Let me bring this answer, just copy it, so you understand better. This is just equal sign. Let me take this off. And we've got also sine alpha, sine beta. Sine beta, here, sine alpha. And if you can see this thing, those two is going to cancel each other out. This thing, sine alpha and sine alpha. And we would have something very close to that answer, but instead of mg sine alpha, we will have mg sine beta. And here below we've got the same answer, which does not change, alpha plus beta. So this is our answer number 2. Can it be our answer? Definitely, because we have mass, g is constant in our case, and alpha and beta are given. That's why let me highlight it. And you can see those two answers. N2, mg sine alpha, N1 is mg sine beta. Okay, this is the end of this video. We will solve problem number 3 in the next video. If you have any questions, you can write me privately. But I hope that everything is pretty clear. Yeah. Thanks for your attention. Goodbye.